Welcome to Chapter 8 in Exercise Metabolism and Bioenergetics. All right, so we have to figure out how we're going to produce energy and utilize it best. The human body needs a constant supply of energy to function properly and meet the demands of exercise. And there are a few different ways that we're going to do that in the most efficient way, but we'll talk through those. The energy molecule used to do cellular work is called adenosine triphosphate, ATP. It is the most important energy molecule when it comes to being able to exercise and produce force, produce movement. It is made from the food substrates consumed in our diet. And so thinking through the first law of thermodynamics, getting into a little bit of physics, first law of thermodynamics states that energy can neither be created nor destroyed, only converted from one form into another. So the fuels used to create ATP are glucose from carbohydrates, free fatty acids from fat, amino acids from protein, and ketone bodies. These fuels are mostly obtained through the diet. Carbohydrates in the diet are broken down into glucose, which can produce ATP quickly via the process of glycolysis. And glucose is stored in the form of glycogen. The amount of glycogen that can be stored in the body is much less than the amount of fat that can be stored. Free fatty acids are the byproducts of the breakdown of stored or consumed fats. They are oxidized exclusively via the aerobic pathway, which uses oxygen to create ATP. Amino acids are the byproduct of protein breakdown or digestion. Amino acids can be metabolized via oxidative phosphorylation, but this is not typical in healthy people because protein is usually reserved for muscle building rather than ATP production. So primarily carbohydrates and fat sources are how we're going to best create energy. Ketone bodies are produced by the liver during periods of low energy intake or low carbohydrate availability. They can be oxidized via the oxidative phosphorylation pathway to create ATP. And so if you ever know anybody who is on a keto diet and they're not really taking in a lot of carbohydrates, this is one of the ways that they can the body works around not having a lot of carbohydrate availability. Exercise is categorized by two factors, right? Intensity and duration. The higher the intensity of the activity, the shorter the duration must be. We can't sustain high intensities for very long. And this is kind of the basis of it, the energy systems that allow us to work at a specific rate or intensity. To perform exercise, the body needs fuel, which comes from food that is broken down through a series of chemical reactions to provide energy in the form of ATP and heat. The ATP phosphocreatine pathway is the simplest and fastest way to generate ATP. This system can only support short duration activities because the supply of phosphocreatine is limited. And that is one thing when we get to the supplementation chapter, why you'll see that people find a lot of benefits to supplementing with creatine phosphate. This is one of the reasons. But the ATP phosphocreatine, also known as the phosphagen system, is your shortest and most efficient energy system. Glycolysis is an anaerobic process and generates ATP quickly, but not a tremendous amount. So the end products of glycolysis are ATP and pyruvate, which can become lactate under anaerobic conditions. So anaerobic being those conditions that are without oxygen. So it's kind of like our in between our middle energy system. And then oxidative phosphorylation is a process that uses oxygen to create ATP from substrate molecules at a relatively slow rate. So although oxidative phosphorylation is generally slower, it's used in our aerobic energy systems, it also produces the most ATP. Oxidative phosphorylation can use pyruvate, starting from glucose. It can use fatty acids, amino acids, or ketone bodies as substrate molecules. This oxidative metabolism produces carbon dioxide as a byproduct, which is then exhaled. The most important factors determining the type of energy use during exercise, again, are the intensity and the duration. And so the intensity and duration of an activity are inversely related, which means that as the intensity goes up, the duration must go down. Steady state exercise is defined as a situation in which a person engages in the same level of activity without increases or decreases in intensity for several minutes. Intermittent exercise is defined as frequent changes in the work requirement, i.e. intensity, during an activity. Exercise increases metabolic rate, and breathing rate increases in proportion with it. So obviously when we are exercising, we're using more energy, and our level or rate of metabolism increases. When breathing rate becomes too rapid to allow talking, the body is shifted to oxidizing almost exclusively carbohydrate to fuel the activity. So when we shift out of that steady state, out of that aerobic or oxidative energy system, we kind of have to, the intensity is increasing, and we have to shift a little bit more potentially towards glycolysis. Lower intensity activities use a higher percentage of fat as a fuel, but generally do not burn a lot of calories unless performed for a very long time. Whereas higher intensity activities have a higher percentage of energy coming from carbohydrate and usually burn more total calories in a given time. Daily food energy intakes need to be adequate to maintain a healthy body weight, allow for proper bodily function, and support physical activity. If our daily food intake is matched to our energy needs, a person is said to be in energy balance. Obviously, this is important when it comes to fat loss or to muscle building. If we're in either a growth or a cutting direction, or if our goal is one way or the other, we have to be mindful of where our energy balances are. And then calories are the basic unit of energy provided by food, and the total number of calories that a person burns in a day is called the total daily energy expenditure. The resting metabolic rate, RMR, is the minimum number of calories needed at rest to keep a person alive and meet all of their functional needs of the body. The thermic effect of food, right, TEF, is the number of calories that are used to digest a meal. So that's important to realize that even there is an amount of energy being used just to metabolize and digest our food. And then important things when we think of the total picture of calorie burn and energy use are non-exercise activity thermogenesis, which is NEAT. And then this is when we're all involving burning calories in activities that are not structured exercise. And then EAT, which is exercise activity thermogenesis, is the calories burned during structured physical activity or purposeful exercise. And then, so just thinking through an important, our list of important concepts. Obviously, we talked about some of these, but the first law of thermodynamics states that energy cannot be destroyed or created, but merely converted from one form to another. Glucose is the simplest form of carbohydrate used by the body for energy. Glycogen is glucose that is deposited and stored in bodily tissues such as the liver and muscle cells. It is the storage form of carbohydrate. So one molecule of glycogen is going to have a significant amount of glucose in it. Triglyceride, the chemical or substrate form in which most fat exists in food as well as in the body. An essential amino acid is, there are amino acids that must be obtained through the diet as the body doesn't make it. There are 9 essential amino acids of the 20 total. Non-essential amino acids, these are amino acids that can be synthesized by the body and do not, under normal circumstances, need to be obtained in the diet. Gluconeogenesis is the formation of glucose from non-carbohydrate sources. So this is where the body is converting proteins and fats into sugars, into glucose. Thinking through just basic categories, aerobic and anaerobic. Aerobic processes are those relating to involving or requiring oxygen. Anaerobic is process relating to the absence of oxygen. So then our three energy systems, the ATP phosphocreatine, aka the phosphagen, these three are very important that you know the differences between these three. So in the ATP phosphocreatine system, it's an energy system that provides energy very rapidly for approximately 10 to 15 seconds at most via anaerobic metabolism. And example exercises that predominantly use the ATP phosphocreatine system would be short sprints, probably less than 60 meters of sprints for most people, Olympic weightlifting, jumping, and plyometrics. The glycolytic system is your middle of the road kind of. It's still considered an anaerobic energy system, but in the glycolytic system, a metabolic process that occurs in the cytosol of a cell that converts glucose into pyruvate and adenosine triphosphate, ATP. Anaerobic glycolysis refers to when this process occurs in the absence of oxygen. It lasts longer, with a capacity of approximately 30 to 60 seconds of duration. Example exercises that predominantly use the glycolytic system include most of our strength training in that 8 to 10 repetitions range. 8 to 12 repetitions range. Most exercise, right, if you're doing some strength training, it's going to last in that 30 to 60 seconds of a set, is going to fall in that category. When we think through the oxidative system, this is the most complex of the three energy systems, and it undergoes a process that uses oxygen to convert food substrates into ATP. This process is called oxidative phosphorylation, and it's defined as an aerobic process because it needs oxygen to complete the actions. And then example exercises that predominantly use the oxidative system are going to be longer, right? Jogging and running for an extended period of time, biking, cycling, swimming, things that are more steady state, longer duration. The electron transport chain, right? This is important in thinking through the energetics of it. A series of protein complexes that transfer protons and electrons received from the citric acid cycle through a series of reactions to create adenosine triphosphate. EPOC, excess post-exercise oxygen consumption. This is the state in which the body's metabolism is elevated after exercise, and this is one of the reasons that high-intensity exercises can be really beneficial, because it's not so much the calories that are burned during the exercise, but the fact that you're still in a state of needing to consume more oxygen after you're finished the exercise. That excess post-exercise oxygen consumption that you're going through will lead to an elevated metabolism rate and more caloric burn after exercise. Resting metabolic rate, RMR, is the rate at which the body expends energy calories when fasted and at complete rest, such as asleep or lying quietly. Exercise activity thermogenesis, EAT, is the calories expended through structured exercise or training. The thermic effect of food is the energy required to digest, absorb, and process nutrients that are consumed. And then NEAT, right, our non-exercise activity thermogenesis. This is the energy expenditure through daily activities outside of structured exercise, such as walking, completing household chores, and just taking the stairs instead of the elevator. So in general, in summary, I think these are our big points. Thinking through exercise metabolism and bioenergetics, it's just important to note, especially, just make sure that you know the three energy systems specifically, and how they are different. There are 2 anaerobic, 1 aerobic. They all use ATP. It's just a matter of converting the energy to get to that point, and how your body has to go through different processes in order to achieve that